Okay, today's exercise on the ballistic pendulum. And this is the apparatus we will use. Here we have a gun that's going to fire the bullet. It's a brass ball. I've already determined the mass is 69.5 grams. And this is lowercase m, and this is uppercase M, the catcher. This is marked here, 274.3 grams. We're going to fire this ball from this spring gun into the holder. The holder will rise, and there's a pole here that will catch it. We have to know, as you saw from the lecture, the height to which this rises, and we want to know the height of the center of mass. Now, ignoring this little pointer here, notice that there's a screw here. And the first thing I did was measure the distance from the center of the screw, which is the center of mass of this assembly, to the top of this platform, and that measured 5.6 centimeters. After we fire the ball and we move it up here, I'll measure the distance from this screw again to the platform, and if I call this H sub 0, I'll call this H, and the distance there, or Y sub 0 and Y, the distance that the system rises is equal to the difference in those two heights. So first thing I'll do is load the ball. Make sure that this is here. And I will do this 3 times and get 3 different measurements. Okay. So for my first measurement, that's exactly 13.5 centimeters. And I'll do this 2 more times. And we'll take an average to determine the initial velocity of this ball before it hit the catcher. What was its velocity as it left the gun? And again, I'll measure the height, the new height. It's exactly 13.5 centimeters again. That's a little unexpected. It's usually not that accurate. Not repeatable. Is usually a couple of millimeter difference, but in this case, there wasn't. And the third and last time, and again, let's see how high we are. Well, that's going to be a surprise. It's 13.5 centimeters again. Okay, that's part 1. Now, we're going to verify that. How do we do that? Well, I'll remove the ball. And I'll move this up out of the way. What we're going to do now is to shoot this ball. And we know that this system is horizontal. We're going to shoot it. We'll measure its height to the ground, as we discussed before the lab started. We know the distance it has to fall, and that's not the distance from the center of mass. It's the distance from the bottom of the ball, because that's what's going to hit the floor. So we can determine, knowing that its initial vertical velocity is 0, we know the time. We'll measure the distance, and we can get its horizontal velocity, and then compare that velocity with the velocity obtained when the ball went into the catcher. So what this looks like is this. And we just fired this ball across the floor, and it landed somewhere near my foot. And what I'm going to do here is take a piece of paper, white piece of paper, and some tape. I'll have to get some tape. Here we go. Oh, there. Then I'm going to tape this to the floor. put a piece of old-fashioned typing carbon paper on top of it. And I will fire the ball again. When it hits the paper, it's going to leave a mark. The carbon paper will leave a mark on the floor below it. And I'll do this a couple of times. Nice backstop, comes right back to me. And I'll do this a third time. Okay, now, I'll remove the carbon paper. And you notice I have 3 dots. That's the 3 spots where the ball hit. All I have to do now, notice how close they are, how repeatable that was. All I have to do now is measure that distance to the point of release. Now the point of release is here with the gun with this extended. So what I have to do, I have to measure the distance from here to the ground and then the distance to the spots on the floor. That's a little tedious. It'll take the 2 of us a few minutes to do that, to transfer, because I can only measure from the bottom to this platform, from the platform to the table to the floor, and add the 3, and then I have to determine a straight spot and then measure. So we will do that off camera, and I will provide that data to you.